Hello, welcome to the video on different types of starters which we use in three-phase induction motor. In the previous video, we discussed about two types. Now, in this video, I am going to discuss another two types of starter which we come across in three-phase induction motor, that is auto transformer and rotor resistant starters. So, in auto transformer starters, if you observe, this is the auto transformer starter arrangement where we have this three-phase supply. We have switches where we have six positions here for this three-phase supply. During start, the position of this three-phase will be to 1 and 3 and 5. So during start, as I said, this resistance we are having in the auto transformer, where this is a variable. So connecting to this and by adjusting the transformer to different we can vary the voltage in this auto transformer. So we apply the reduced voltage, because when you give this three-phase supplies to this connection point 1, 3 and 5, this auto transformer would be in star connection, and as we have discussed in the previous video, the phase current, phase voltage will be 1 by root 3 times of the supply voltage, so line voltage. In that case, we have a reduced current at start. So during normal operating condition, this three phase supply will be switched to 2, 4 and 6. So in that case, this will be in delta connected during the normal operation, where we apply the supply voltage to the stator winding, which is safe during normal running condition. So this suitable arrangements, which has a changeover switch, when the switch is in the start position, as I said, 1, 3 and 5. Okay, the stator winding is supplied with reduced voltage. It can be controlled by the step tappings also, which is provided in the auto transformer. So we apply a reduced voltage by a fraction which is called X, which is used in the auto transformer as shown in this diagram. So as soon as this auto transformer, a fraction, when you give a supply to this auto transformer, we can vary the auto transformer based on the voltage we require also, and even otherwise it gives a reduced voltage 1 by root 3 times of the supply voltage at start. So during running condition, it becomes in delta. So as shown here, so the ratio we discussed between very similar to star delta starter. Here the TST by TFL is equal to X square into ISC by IFL whole square into SF, where X is a fraction of reduced voltage and resulting in reduced current. It is 1 by 3 times of it. So coming to the rotor resistance starter. This rotor resistance starter, to limit the rotor current, we normally employ this rotor resistance starter. That means each of the rotor phase is connected via the slip rings to the external resistance, where we call this external resistance as Rx. So each phase, if you observe, it is connected via the slip rings, the brushes and to the external resistance. So we are adding each phase an external resistance separately. So this method is mainly employed for slip ring rotor. So the external resistance inserted in each phase of the rotor winding through the slip and brush assembly. Initially, this position will be at here. That is, the maximum resistance will be included in the circuit, because we know in three-phase induction motor, during starting, we need to have a very low current. So as the motor gathers speed, normally when it gathers speed to 80% of it, this resistance is gradually cut out, and the operation can be manual or automatic during normal operation. So we have seen the starting torque is proportional to rotor resistance. So hence important, if you have a very low resistance, high current and low torque. So hence important advantages of this method is not only starting current is limited, but starting torque of the motor also gets improved. So the only limitation of the starter, it can be used for slip ring. We cannot use this for squirrel cage induction motor. So to begin with the construction, so let us assume two conditions here. That is, the motor starts against a constant torque, and the rotor current fluctuates between I maximum and I minimum, which is denoted here. That is I maximum and I2 minimum. Now, this is the external resistance which is connected to the start point of one of the face of the rotor. So this is one of the face. This is the start point which is connected to external resistance Rx. So this external resistance is divided into equal section. Let us assume that is divided into n section. So each section, equal section, has a resistance of Rx1, Rx2, Rx3. It goes on, and this is the nth Rn, that is the resistance at this nth position. So this 1 2 3 4 5 so on is called as studs. So each section at starting and ending, we name that as a stud. So this is a section which has a starting stud at 1. So with this we can understand how the rotor resistance is included during the start and gradually cut off and during the normal conditions. But when included at start and gradually cutting out, what would be the current in the rotor? So it consists of rotor resistance, as I said, the face of the rotor, and this external resistance which is divided into equal section Rx1, Rx2, so on. And the current flowing here is also considered to be I maximum and I2. When it is I maximum, when the pointer is at exactly at the position of the studs 1, the current would be maximum. If it is at the positions of 2, it is said to be maximum. When the stud or the pointer is moving from 1 to 2, that is when it is leaving 1 and moving towards 2, the current becomes minimum. So between this section it becomes minimum, and at every point of this studs the current becomes maximum. So with this condition, if you observe the resistance when the pointer is at 1, it includes all the resistance with this rotor face. So it is named as R2. As it moves to point 2, that is stud 2, the resistance, this Rx1 is being cut off, and the remaining resistance still stud 2 from this rotor resistance phase is R2. Similarly, it goes on. At stud 3, it is R3, it goes on. So we keeping this, now we will derive an equation because how the resistance of this at every stud or the sections of the resistance can be calculated. So as I said, E2 is at standstill rotor EMF per phase. So when the handle is moved to stud 1, so I2 maximum is the general equation we have S1 E2 by R1 square plus S1 X2 whole square. As we know, during normal conditions, the slip starts decreasing. So at start, the slip is 1. So at start, let us say the slip is S1, and as the stud keeps moving and resistance is cut off, that means the rotor is running condition, the slips also start decreasing. So we will denote the slips as S2, S3, as it moves towards the studs 2, 3, 4 till the end stud. So while moving to the stud 2, the current reduces to I2 minimum, given by I2 minimum is equal to E2 by R1 by S2 whole square plus X2. Remember this generalized equation, I am dividing by S1 so that we get the S1 at the denominator of this R1. So each cases we have here also with minimum. Similarly, when it reaches at stud 2, the current is maximum. So R2 will be the resistance at stud 2, and the slip introduced at stud 2 is S2. But during leaving the stud 2 and going towards stud 3, the slip also changes to S3. Therefore, we have R2 by S3 here in the denominator. So this goes on till the nth stud. So finally, we equate the I2 maximum of each stud up to n stud, and we equate this currents are equal at every stud. That I2 maximum is same at every stud. In that case, we equate the equations of each stud maximum current values. So in that case, if you observe, in order to make the equations to be equal, where we have numerator is equal, the denominator x2 is common here in all the denominator, but only thing the first term is varying. Therefore, if you equate these two, then the current at a point of each studs are equal. So when when you equate it, R1 by S1, R2 by S2 will be equal to R2 by S1. Sn. Similarly, if you take the minimum rotor current when it is leaving from stud 1 to stud 2 or stud 2 to stud 3, there is a minimum current in the rotor which we derive with this equation, and we equate it. If similarly with this equation, if you notice, the numerator is same, the denominator x2 is same, but only thing we have to equate R1 by S2 is equal to R2 by S3 and Rn minus 1 by n minus Sn. So when looking at these two equation, from this 1 and 2 equation, we can see that S2 by S1 is equal to S3 by S2. Just look at this, S2 by S1 is equal to R2 by R1. I'll take it as one term here, one term here. When coming to the next term, it is R3 by S3. So S3 by S2 will be equal to R3 by R2. It goes on, and the final equation you are going to take these two here. So that is R2 divided by Rn minus 1 is equal to, which we equate this entire equation to K. Now we know that K is constant, but at start S1 is equal to 1. So when you relate this, R2 by R1 is equal to K. R2 is equal to K into R1. But at start, R1 by S1, R1 is equal to S1 into R2 by Sn. If you take these two equation, R1 by S1 is equal to R2 into Sn, but at start S1 is equal to 1. Therefore, R1 is equal to R2 by Sn. So with this equation, we can proceed as I said, R2 is equal to K into R1, where R3 is equal to K into R2, which can be written as K square into R1. So in terms of R1, we can write all the resistances at each step. That is R3, R2, R4, etc. So while relating this equation, as we know, R1 is equal to, if R1 is known, we can calculate R2. So R2 will be K into R1. R3 will be K square into R1. Then R4 is equal to K cube into R1. Looking at this, we can generalize the final resistance R2 will be equal to Kn minus 1 into R1. So from the last expression, we can write K is equal to R2 by R1. Kn minus 1 is equal to R2 by R1. So if you want to remove this Kn minus 1 at the suffix, we can power this to the right side. So this becomes 1 minus 1 by n minus 1. But we know R2 by R1 is Sn in the previous equation. That is R2 by R2 by R1 will be equal to Sn. So in using that equation, we can write this as where R2 by R1 as Sn. If you know the number of studs, okay, and the slip, you can calculate the constant K. And if you know R1, you can calculate any section resistances. This is how we calculate the resistance of the rotor side which is been inserted. Thank you for watching.